Welcome back to part 2 of this DX1 switch mode power supply repair. I've replaced the bridge rectifier, this 10 ohm resistor, the caps. I've replaced all the caps on the primary side with lovely Nichicon caps, these three also, and if it runs correctly then we'll replace the rest of the caps as well. Let's just plug it all back in. I've replaced the fuse with a quick blow 4 amp and a couple of X2 capacitors across the switch. Yeah, so this is the link which turns it from 100 volt mode, which puts it through this voltage doubler or trebler, or when you switch it out it turns it back into full bridge rectifier mode. This is the cap that is shorted out, which might actually have saved the day, so maybe we will give that a go if we can get it working at 110 volts first. We'll just plug her back in. To be on the safe side, we're going to use my light bulb limiter. I can use this switch here globally to turn everything on and off. We have to use this step down transformer, and I've measured the output of this. It's actually 120 volts, so we'll see what happens. And then we're going to plug the output of that transformer straight into the DX1 input here, and then I can leave this switch in the on position, and I'll also leave this on the on position, and I can turn it on and off from that main switch. And we'll just put the probes on the first output, which is the minus 15 volts for the audio. I'm just going to cover up anything expensive before we power it up, just in case anything explodes. Oh, we have a minus 15 volt rail. Now that is looking really good. So let's see if we have the plus 15. This is on the analog side. Yeah, plus 15. And then we check the digital. We need the earth from this connector. This should be the minus 15 digital. Excellent. And the plus 15 digital. Fantastic. And this should be the 1.2 volts. It's measuring 1.7. Interesting. Soft load. And the 5 volt rail plus 5.46. Well, that's really good. And you can see it peaked at 36 watts and settles down at 9 watts, 10 watts. Okay, well that's working great. I think we're going to give it a go. So it's going to be used in England with 230 volts. So let's switch it into its 200 volt mode. So also soldered some potential dry joints underneath there, which is really good because hopefully this will be the last time it has to be out. So I'll just plug these in and reconfigure my bench. Right, we now have 230 UK volts coming straight in. Fingers crossed. See what happens. Wow, minus 15 volts. Brilliant. Okay, let's just check. Yep, plus 14 volts. And we'll just swap to the digital ground, and then we should have the minus 15 digital. Fantastic. The 15 volts digital. The 1.2 is still 1.7, and the 5 volts still 5.4. Okay, well that's amazing, working at 230 volts and 7.2 watts. 2 watts on a step down transformer. So both the plus and minus 15 volt rails are using voltage regulators. The 1.2 volt rail is using this circuit here. So I'll check all these resistors. That's actually derived from this 5 volt rail. So yeah, not sure what to think of that. I'm going to have to remove all this glue because I'm worried about the moisture leaking into it. And here you can see my Saxo Human replica that I have made with all the spare components, including this nice altar table. And we're going to replace all the caps with nice Panasonic ones. And also, this is the switching regulator that drives the MOSFETs. And I did attempt to power this up from my bench power supply from the 15 volts DC input rail here for the power. But obviously there is not enough energy in the circuit to drive enough feedback to the optocouplers to keep it going. So, but it measured 48 milliamps, so it wasn't sure. Look at that, what a beauty to behold. It looks absolutely fantastic and beautifully clean on the underside as well. I'm really happy with that. And look at the handmade corner cutouts. Be interesting to know who did that. And also I noticed there's a bit of grease on there, so I think I might have to put a bit of heatsink compound on. Okay, so with the new caps in, yep, we're still working. Let's just double check all the voltage rails. So the plus 15 analog, and we switch to the digital ground. Minus 15, plus 15, and then the 1.2, which is 1.7, still 1.7, the 5.4 volts. And if we just check with the thermal camera, we can see there's a couple of resistors there. They're starting to get a bit toasty. They are the 5 watt 15k ones. And now it's been on half an hour. They've reached a toasty 104 degrees C. So I've used my homemade decade resistor boxes to add a load to the power supply. It's been on an hour now. I've been monitoring the voltages and nothing seems untoward at all. So these have stayed at 106 degrees, which I think is actually probably quite normal. So we've got 154 volt drop over this resistor. And if we just check the other one, 158. So that's just over 1.6 watts or something like that. So I do have some larger wattage resistors, but they're actually a smaller surface area, so I'm not sure if it's going to help us or not. So looking back at the schematic, we can see this trim pot which comes from the 5 volt line. It also has a feed from this minus 15. And I'm wondering whether we can adjust this circuit to see if we can get more closer to the 1.2 volts. Here's a little trim pot on the board. So we can see if this does anything to those voltage rails. We'll take it slowly. Yeah. So I can tweak this voltage rail. But it was okay before, so I'm wondering whether when you put a load on this now, it might drop below the 5 volts. And I can get the other voltage rail down to 1.57. So not massively different. Was hoping to get much closer to 1.2. I'll just do a quick sanity check on my key fleas. And yeah, they're actually matching my old Fluke multimeters quite well. Okay, so the curiosity got the better of me and I put those 7-watt resistors in. And as I expected, they're now reading nearly 120 degrees. So the large surface area really does make a difference. So, okay, I've taken them out now. Put the old ones back in. And we're back down to 108. I was quite hoping that the newer resistors might have dissipated more heat better. And we're now at 6.6 watts. So here's my arch enemy. It's a little bracket that fits in down here, screws in from this side, and that allows you to attach to the angle bracket on the side of the synth to keep it in place. Okay, so after all that, I figured out that the best way to do it is you just slide it through these regulators here, and once you've slid it through you can then screw it quite easily.
So much we're not, so much we're not, so much we're not, so much we're not.
We have these larger screws here which confused me for a second until I realised that they're there to tie down these wire looms, which is a really nice touch. And there's one on the other side here as well. So let's get them in.
When the still sea conspires in armor, and her sullen and aborted currents breed tiny monsters, true sailing is dead, dead, dead.
And luckily they've made a hole for us so we can adjust those 5 and 1.2 volt rails. And measuring 6.6 watts. It's been on for about 4 or 5 hours now. There's a little umbilical cord connecting to the main power supply. And yeah, 1.6 volt digital. The 5 volt rail. The minus 15. It's taken almost every multimeter I got. Plus 14 digital. And then the plus 14 minus 15 analog. So that's looking good. And one last check of the temperature, and now it's in its case. There's nothing really too alarming to write home about at all, which is fantastic. Now obviously this is off-road, it's not connected to the DX1, and we don't know if the DX1 survived the overvoltage situation, but I think there's a good chance that it's going to do well. Nothing red short on the power supply rails. So yeah, guess you'll have to see me on the next episode where we plug this back into the DX1. Catch you next time.